Again, I could rescaffold the view, but I just want to kind of show the changes happening in real time so you know what's going on. I can now say blue shirt. And away you go. So basically, we've evolved our schema, we've added a new column, and the beauty is we didn't lose any data. If I want to change things more, let's say, for example, let's make the name property here. Right now, if you look at it in the Server Explorer, you can see that the name property is nullable, which is the default in VS. So you can say, or in SQL, so it says nullable equals true. Let's make it non-nullable. So one way to do that in code first is I can actually just add what's called a required attribute, like so. I could then go to the package manager console, and I'm just going to say add migration again. And we're going to name this change product name required. Again, this will look at my schema to look at the database, see what the difference is, and say, oh, we're going to alter the column to make it nullable or non-nullable. And I can then go ahead and say update database. This will apply the migration, and now if I hit refresh and click on the name, you can see nullable is false. So pretty easy way you can make rapid changes to your schema and your objects and keep your database in sync. The beauty about this is, so I'm naming each of these migrations, and so you can see here I have different timestamps for each of them. If I ever want to roll back to a previous state, I can also do that. I can say update database, target migration, and I could say add product price. Like so. And this will actually roll back my schema to the previous state, again, preserving my data. And so now I no longer have it be nullable. If I went and looked at this again, what I should find is it's rolled back to be nullable. And then if I want to roll it forward, I can do that again and roll forward either to the latest state if I don't specify any migration, or I can name any migration I want in order to go forward. And the reason for that is because there's both an up and a down method, and so I know how to walk back and walk forward with the changes and preserve the data. People often ask questions, kind of rename columns. Yep, there's a helper method there called rename column that you can do. You can execute arbitrary SQL if you want. So if you want to do things like change a price from a decimal to a different format, that it would be a destructive change if you just change the data type. You can actually write inline SQL as part of your up-down statement to put it in a temp variable and convert it yourself as part of the migration. You can do lots of power. It also is a provider model so that you can use it against Oracle, you can use it against MySQL, or other types of databases as well. And what's nice is when you're actually all said and done, and you're ready to actually deploy this app that has the changes, you can also go ahead and let's bump the font up here. Ooh, that's very big. Let's make it. You can also go ahead and just say update database script, and you can say source migration. So in other words, where are we starting from? And we're just going to say initial database, and then you can say target migration. Where do you want to actually generate the migrate script to? And so I could either pick the most recent version, or just say sort of change product name required. So change product name required. Hopefully I spelled that right. And when I run that, instead of actually applying it to the database, it's instead going to create the .SQL file automatically for you. So you could pass this off to a DBA, or a question that came up in the Azure discussion earlier, how do I change my SQL Azure database? Cool thing is you can just save this to disk or copy paste it into the SQL admin tool, execute it against your SQL Azure database, and you've just migrated your schema. And so this gives you a way to easily deploy your initial app, and then every time you do a code update that changes the database, this provides an easy way for you to do an incremental change of your schema on your production box. But anyone that still wants to know exactly what's going on under the covers, the good news is you can just look at the .SQL file, you can hand tweak it before you deploy it if you want to, and you're still in full control as part of the system. Other nice thing about this is it integrates well with source control. And so because these migrations can be checked in, and because there's a timestamp, if you have multiple devs working at the same time on a project, they can each check in separate migration scripts, and then you can actually resolve them together at source control time. And everything can be automated from the command line. So in addition to doing it from the PowerShell window that's built into NuGet, You can also do it from a build server or a continuous integration system, and you can also just run it from a vanilla command line within Windows. So pretty easy way to take advantage of it. Again, you can use it in any type of .NET project. It's not tied to ASP.NET MVC4, and the beauty is it's actually now shipping in released form. And so if you go to NuGet and just say update package entity framework, you get the latest version and you can do all these things yourself. So hopefully it makes it a lot easier. You'll see even more support coming out this spring, so that when you actually use, for example, right-click and hit Publish inside Visual Studio to do a web deploy, we'll actually integrate with this as well, so that we can now do automatic database diffs as well as part of publishing, and kind of streamline that process end to end. So it's a feature a lot of people have asked for. Other frameworks, I should mention, do have this. Rails popularized this. Other frameworks have migration scripts as well. We try to take some of the best ideas, and then I think some of the entity framework integration, which allows you to kind of integrate with the strongly typed model of your POCO classes, helps streamline it hopefully even more, gives you a lot of power, a lot of productivity, and hopefully makes your lives as developers even easier. So that's migrations. Moving along, other new features. Web APIs. How many people here are exposing web APIs inside their apps? Cool. How many people here have heard of web APIs? Cool. How many people here drink coffee? No, same number, fewer people than last time. But you know, one of the things we're investing in pretty heavily with this release is web APIs, both calling them as well as generating them within your application. And we think this is kind of a pretty big step forward for applications going forward. You know, we think the support that we have that's new in MVC4 will make it really easy to build them and do some cool things with them. Before we get to the what, though, let's talk a little bit about why. Why should you actually care? Well, fundamentally, using web APIs and building web APIs of your own are going to enable you to build even richer apps and have even richer experiences for more clients. And by clients, I mean browsers, obviously. And so all your web APIs you can call from jQuery, you can call from JavaScript or any AJAX framework. You can call them from Silverlight, you can call them from Flash, you can call them from a Win32 app or WPF app. You can also call them from other devices. So if you want to build a Metro app for Windows 8, you can do that. If you want to call it from Windows Phone, you can do it. If you want to call it from an Android or iOS device, you can do that as well. So they end up being a pretty clean way to expose functionality, expose data in a secure way, and basically build richer user experiences against them. Lots of people have built web APIs over the last couple of years. They're kind of multiplying like crazy. And so if you've ever built a Facebook app, you're using their web API layer. If you've ever used a Twitter app on your phone, you're calling the Twitter web API. And you're going to see more and more APIs kind of get opened up over time. The interesting thing about most of these APIs recently is that they kind of fully embrace HTTP. They tend to use HTTP not as a transport protocol, which is what XML RPC or SOAP or the WStar schemas typically used. They have their own kind of higher level explanations of things like errors and success and things like that, and then they just use HTTP effectively to tunnel it across the internet. Instead, typically with web APIs, you're actually embracing HTTP. You care about status codes, you care about headers, you care about URIs, and we want to make sure with the web API work that we're doing in MVC4, we provide a really clean way in order to embrace all that and do all that. And with that, let's go ahead and write some code. So we're going to go back to our Redshirt 4 app and go ahead and expose some web APIs for the data we just created. And so to do that, I'm going to right click and add a new folder. Now you can add web APIs anywhere in your project. So I'm just going to put them in this APIs folder by default. Mostly because I just want to group them in a logical place. But if you wanted to, you could absolutely put them in the controllers folder as well, that you put your typical controllers for serving out HTML or other content. But just to keep it simpler, I'm going to put it in the APIs folder, and I'm going to create a new item and add it in there. And I'm going to select a new template that's in the MVC4 beta called the Web API Controller class. And I'm going to name this the products controller. And I'm just going to get rid of the default stuff so we can build it from scratch. This is what kind of that class is going to look like. And you can see here, There's not a lot there. There's not any conventions or any attributes you need to add by default. All we've done is built a class that derives from a new API controller base class that's built into MVC4. And what I can then do inside this class is expose action methods that I want to make use to implement web APIs. And so I'm going to say I want to have an API/products URI on my website, which I want to use to retrieve all the products from our store. And to do that, I'm going to say return an iQueryable list, like so. And I'm just going to do that against our store DB context. So, and we'll just say return db.products, like so. So pretty simple, just returning a set there. Let's have one other API, and then we'll actually start calling these. And I'm just going to provide kind of a way to retrieve an individual record or product. And so I'm just going to say get ID, and in here I'm going to return a product instead of a sequence of them. And I'm just going to say dbproducts.single d.id is equal to ID. So just like so, I'm basically exposing two actions. I'm using a RESTful-based standard here in order to do it. But I don't have to use REST, so if I want to use a different convention on the URI format, I can. We don't enforce REST, but we have a really nice way to do REST inside these APIs. And what I can do now is just run this app. And then we can start taking advantage of this. Now, we're not going to run it in the browser because these are APIs, and so there's no HTML actually associated with them. Instead, what I'm going to do, just to kind of show off what's happening under the covers, is I'm going to use a tool that you can download called Fiddler that makes it really easy to kind of simulate HTTP traffic to my machine and see the request response payloads and twiddle them so you can actually get a better sense of what's going on. We're going to have a built-in set of tools with the final release of MVC4 that allow you to, so you don't even have to use Fiddler. We'll actually have kind of a default client tool you can use in order to actually test out your web APIs. But for right now, I'm just going to use Fiddler. And so what I can do here is when Fiddler is I can go to the Composer tab, and I can actually enter in a URI I want to hit. And so in this case here, I'm going to hit this /API/products that we created. And when I do that and hit execute, it's going to execute against the server. Fiddler shows its results here on the left-hand side, and when I double-click on it, what you can see here is that by default, we just return back all the products from our database, and they're encoded in a JSON format. And if I hit the raw button, which, there it is, you can see that's what the JSON format looks like. Fiddler has a nice JSON view that I can use, so I can actually see those results directly within the tool. And the beauty here is I just didn't have to do anything with JSON. I didn't have to encode it at all. I get that by default from the API controller. How many people here like JSON? How many people here like XML? How many people here like coffee? So let's say you wanted to see this in XML instead of JSON. Well, HTTP today provides a mechanism to express that. Does anyone know what it is? It's an HTTP header, and it's called, what is it called? It's called accept. It's 6 a.m. my time, that's why coffee is on my mind. But basically what you can do when you send a request to any web server is you can indicate what type of payload you want back or what type of payload you understand. By default, we'll send back JSON from web APIs, but if I want to, I could just say, hey, what I really want is XML, hit execute. You'll notice there's a different icon here in Fiddler, and if I double click on it, instead of JSON, what I'm getting sent back is an actual XML representation of my products instead. And the beauty here is I, as a developer, didn't have to actually do any code in order to support multiple formats. The web API has actually an extensibility API, so if you want to have your own custom vCard or whatever kind of format you want to represent your data, you can plug it in once at the application level, and then all your controllers can automatically support it. And we can basically serialize content in and out